All right, let's dive into some IT today. Based on this metric IT theory document, seems like you're ready to go deeper with tech, not just clicking and swiping, but really understanding it.
Yeah, like you don't have to be a mechanic, but it helps to know how your car runs right. A little knowledge can go a long way with tech these days.
Exactly. So we're not going to turn you into a programmer. But imagine you open your favorite app, and suddenly you see how the data flows. You see the logic behind it all.
It's kind of like X-ray vision, but for the digital world.
So let's start with databases.
Yeah.
Ever heard of database normalization?
Yeah, it's like organizing a library. Imagine all the books just piled up randomly, you'd never find anything. Normalization is all about creating a system, a structure that makes data easy to use.
Right, so instead of this huge pile of books, we make a catalog, organize them by genre and author, but the document goes deeper, talking about data anomalies. It sounds kind of scary.
Well, it can be if your data isn't organized properly. Imagine an online store's customer database. Now they have names, addresses, and orders, all in one big table. Say a customer moves. If you update their address in one place but miss it in another, you've got an update anomaly. Now the same customer has two different addresses.
And that can lead to real problems, I bet, not just digital ones.
Absolutely. You could send packages to the wrong place, miscalculate inventory, even end up with duplicate accounts. Like a messy kitchen, something will get burnt eventually.
Okay, so the document mentions these keys and dependencies. Can you help us with those?
Think of keys as unique IDs, like fingerprints. In that online store example, each customer gets a customer ID. So we can tell them apart, even if they have the same name.
So it's not just organizing, but labeling and linking.
Right, and dependencies are about how data is related, like an order depends on a customer, right? Understanding this helps us structure the database correctly.
It's a chain reaction. One change affects other data. So how do we organize our digital library? The document talks about normal forms.
Think of them as steps in the process. First, you get rid of repeating data, like multiple addresses in one cell. That's first normal form. Then make sure all data is directly related to the key, that's second normal form. And finally, remove dependencies between non-key data, third normal form. Each step refines the structure.
So it's like Marie Kondoing our database, making it neat.
Exactly, like a perfectly organized closet, easy to use.
So we've tamed the data chaos. Now let's talk about the machines themselves, the hardware. I know you're into tech. What excites you about hardware?
Well, it's always evolving, pushing the limits. Take processors, they're mind-bogglingly fast these days.
It's like comparing a horse and buggy to a spaceship. But it's not just speed, right? The document also mentions RAM and storage.
Oh, absolutely. RAM is like short-term memory. It holds the stuff your computer is actively working on. More RAM means more multitasking without slowdowns.
And storage is like long-term memory, right?
Yeah.
Files, photos, videos, all that.
Exactly, and the type of storage matters too. The document compares M.2 and SATA. It's like an express train versus a local train for speed.
Right.
If you're editing big video files, M.2 is much faster.
So if your computer's slow, maybe upgrade RAM or storage. The document also talks about overclocking. What's that?
It's tempting to push your hardware to the max, but overclocking is like redlining your car's engine. You might get a boost, but risk damage in the long run.
So proceed with caution. Let's talk about some of the terms in the document. What are graphics cards and coprocessors? They sound kind of sci-fi.
They might, but they're essential for today's computers. A graphics card is like an art studio for your computer. It handles images, videos, and 3D graphics.
So for gamers and designers, a good graphics card is key. And coprocessors, what are those?
They're like specialists, handling specific tasks. This frees up the main processor to do other things. Like a sound card, it handles audio processing.
So it's like a team of experts working behind the scenes. So we have our data organized and we understand the hardware. What's next in our deep dive?
Well, now that we know what's inside a computer, let's see how they connect with each other. Let's talk about the internet.
Okay, let's get connected then. I've always wondered, how does information travel between computers?
It's not like sending letters, it's more like a network of highways with data zipping around.
So no digital snail mail then. The document mentions centralized and distributed processing. What's the difference?
Imagine you're ordering a pizza. Centralized processing is like one pizza place that does it all. Distributed processing is like a network of smaller places, each specializing in a certain type or area.
So distributed processing splits up the work, making things efficient.
Yeah, and this applies to computers too. Centralized relies on one powerful server for everything. Distributed spreads the work across many devices.
The document also mentions thin clients and fat clients. Is this about the size of the computer?
No, it's about where the processing power is. A thin client is like a minimalist workstation. It relies on a central server to do most of the work.
Like a remote control for a powerful computer somewhere else.
Exactly. A fat client, on the other hand, is self-sufficient. It has its own power and storage.
So a thin client is good for an office sharing resources, and a fat client is good for individuals needing more power. The document also talks about peer-to-peer file sharing, like BitTorrent. What's that about?
It's like a digital swap meet. Instead of downloading from one server, you get bits and pieces from multiple users who have the file.
So it's a collaborative download? That's interesting.
Yeah, it can be much faster for big files. But be careful of copyright and malware risks.
So use it responsibly. I think we've covered a lot in this first part. Databases, hardware, networking, and file sharing.
It's been a good start. And next time we'll go beyond websites and apps. We'll talk about the cloud, the deep web, and even cryptocurrencies.
Sounds mysterious. Can't wait.
Welcome back for more of our deep dive. We laid the groundwork in part 1, but now we're going up the digital mountain, moving beyond the basics, to explore the internet and what it means for us.
Yeah, it's like we learned the alphabet. And now we're ready to write some stories, this Metric IT theory document. It mentions some really interesting stuff coming up. The cloud, the deep web, cryptocurrencies.
Yeah, those are where tech really starts to affect our lives. It's not just how computers work, but how they're shaping the world, even ourselves.
Okay, so let's start with the cloud. It's this magical place where we store all our digital stuff. But what is it really?
Well, it's not some fluffy thing in the sky. The cloud is just a network of servers all over the world, storing and processing data. When you save something to the cloud, you're sending it to one of these servers, so you can access it from anywhere with internet.
So it's like a giant hard drive, but off-site. Convenient, but is it safe? What about data breaches?
Security is important with any online service, and the cloud's no different. Good cloud providers invest a lot in security, but you need to choose carefully and understand it's a shared responsibility. They protect the infrastructure. But you need strong passwords, and to be careful.
So like locking your door even in a gated community. Makes sense. The document mentions different types of cloud services. Public, private, hybrid. It's getting confusing.
Think of it like choosing a place to live. Public cloud is like renting an apartment. It's cheap and easy, but you share with others. Private cloud is like owning a house. More control and security, but more expensive. And hybrid cloud is like a duplex. You choose what to keep private and what to share.
That's a good analogy, like picking the right cloud for your needs. Now let's talk about the deep web. That sounds kind of scary, doesn't it?
It has a mysterious vibe, but it's not that bad. The deep web is just the part of the internet that's not indexed by search engines like Google. It's like library books not listed in the catalog.
So it's not all illegal stuff like some people think.
No. It includes all sorts of things. Private databases, research, company intranets, online banking. It's just info that's not public.
So like a secret stash of knowledge. Speaking of secrets, the document mentions cryptocurrencies. They're really popular these days. But I'm still not sure what they are exactly.
They're digital currencies using cryptography. Unlike regular money, they're not controlled by governments or banks.
So like digital cash, outside the normal system.
Yeah.
But what makes them valuable? It seems like monopoly money.
Their value comes from a few things: supply and demand, technology, market feelings. It's a complicated and unpredictable market, but cryptocurrencies are becoming more accepted as payment and investments.
That's definitely interesting for the financial world. Okay, let's switch gears and talk about data. We talked about databases, the cloud, even crypto. But what about the quality of the data itself?
Data quality is super important these days. Imagine using a map with wrong roads or old landmarks. You'd get lost. Same with data. If it's messed up, outdated, or wrong, it can cause big problems.
The document says data validation is important, like checking your ingredients before cooking.
Exactly. You wouldn't serve food without tasting it first. Same with data, you need to test it, especially in finance, healthcare, and research, where decisions are made based on that data.
So it's not just having data, but having good data. That brings us to big data. Sounds kind of scary, like giant data sets taking over.
It's not quite that dramatic, but big data is changing how we see the world. The document talks about 4 V's: volume, velocity, variety, and veracity.
Let's break those down. Volume, I guess, means the amount of data.
Right, massive data sets, petabytes, even exabytes, huge amounts of data.
And velocity, that's how fast it's made and processed.
So, exactly, a fire hose of info coming at you.
Variety, that must be the different types of data.
Yeah, not just numbers and text anymore. It's images, videos, sensor data, social media posts, all kinds of stuff.
And veracity, is that about accuracy and reliability?
Yes, it's not just quantity, but quality too.
Makes sense, but with all this data, what do we do with it?
Big data analytics helps us find meaning in it. We can uncover patterns and trends that we couldn't see before.
So it's like a super-powered magnifying glass.
Exactly. And these insights can be used for so much: predicting customer behavior, optimizing business, advancing science, improving public health.
Sounds like there's a lot of potential. But the document also mentions concerns about big data, like privacy and security. With all this personal info, how do we protect it?
That's a very important question. As we use more data-driven technologies, we need strong laws to protect our information.
It's like building a fence around your digital garden. But even with fences, there are still data breaches.
Absolutely, data breaches are a big worry. We need to be careful and protect ourselves. Use strong passwords, be careful what we share online, and stay informed about the latest threats.
So we all have a role to play, individuals and organizations. Now let's talk about technology and education, something I'm really interested in. The document highlights some cool things happening, like online learning and personalized tools.
Yeah, technology is changing how we learn. It's making education more accessible and engaging. Online platforms offer tons of courses and resources. You can learn from anywhere at your own pace.
It's like having a university right there on your computer. And personalized learning tools can adapt to different learning styles. That's amazing.
It's very different from the traditional classroom. But we need to remember that technology is just a tool. It can help, but it's not a replacement for good teachers or for human connection, which is important for learning.
So it's about finding the right balance, using technology to make learning better and more engaging. Okay, let's move on to healthcare. The document talks about telemedicine, wearable trackers. And AI diagnostics, it sounds futuristic.
Tech is revolutionizing healthcare, from diagnosis and treatment to how we manage our own health. Telemedicine lets you talk to doctors remotely so more people can access care, especially in rural areas.
It's like a virtual doctor's visit. Very convenient. And those wearable trackers, they monitor everything, heart rate, sleep, activity, so we can make healthier choices.
It's like a personal health coach right on your wrist. And AI can analyze medical images, help identify risks, even assist with surgery.
Technology is giving power to patients and doctors. But with all powerful tools, there are ethical concerns.
Definitely, data privacy is a big one. And there's the potential for bias in algorithms. We need to make sure these technologies are used responsibly and ethically, putting patient safety first.
It's about finding the right balance again, using tech to improve healthcare without compromising ethics. Now let's shift to the environment. The document talks about green computing and using tech to help with environmental problems.
Technology can be both a problem and a solution for the environment. Green computing is about reducing tech's impact, things like energy-efficient data centers and sustainable manufacturing.
So being mindful of our digital footprint and making choices to reduce it. But tech can also be used to protect the environment, right?
Oh, absolutely. Sensors and remote sensing can track deforestation, monitor air and water, even help us understand climate change. And renewable energy, like solar and wind, are becoming better and cheaper, offering alternatives to fossil fuels.
It's great to see tech being used to help the planet. It's not just about gadgets and apps, but about addressing the big challenges facing humanity.
Exactly. And in the final part of our deep dive, we'll explore how tech is shaping the future of work, communication, and even society itself. We'll talk about AI, digital communication, and the ethical implications of all this.
Sounds like a lot to cover. I'm excited for the final part. Stay tuned for the conclusion of our deep dive. We're back for the final part of our IT deep dive. We've covered a lot of ground, from databases to the cloud, even cryptocurrencies.
It's been quite a journey, and now we're at the summit. But there's one more giant to talk about: artificial intelligence.
Yeah, it feels like AI is everywhere these days, from recommendations to voice assistants.
It's definitely captured our attention, a mix of excitement and maybe a little worry. But this Matrix IT theory document, it looks at AI from both sides, the potential and the risks.
Right, it's not just about robots taking over, although that's fun to think about. What struck me is how AI is already part of our lives, often without us even realizing it.
Exactly. It's not just futuristic stuff. AI is powering the algorithms we use every day, our online experiences, news feeds, even navigation. It's about machines learning from data, finding patterns and making decisions, sometimes better than we can.
So it's not replacing us, but helping us, making better choices, automating boring tasks.
Right. Think about medical diagnosis. AI can analyze images really well. Sometimes it sees things doctors might miss. It doesn't replace doctors, but it gives them better tools to make decisions.
The document also mentions personalized education, AI tailoring learning to each student. That could be a huge change for education.
Imagine every student having a virtual tutor, adapting to their needs, giving personalized feedback. AI could make quality education accessible to everyone.
It's exciting to think about the positive side, but the document also mentions risks like job displacement. If machines can do more, what happens to human workers?
That's a valid concern, and we need to be prepared. The key is to focus on skills that AI can't do. Creativity, critical thinking, problem solving, emotional intelligence. Those human skills will be even more valuable.
So we need to adapt and evolve alongside AI. The document also talks about algorithmic bias. I'm not sure I understand that.
It's an important issue. AI algorithms learn from data, and if that data has biases, the algorithm learns them too. Imagine a hiring algorithm trained on biased data. It might unfairly favor certain candidates.
So it's like biases get built into the system.
Exactly. We need to be aware of these biases. Design fair algorithms and hold developers accountable.
It's a tough challenge, but important if we want AI to be good. So it's not just about the tech itself, but about the values and ethics behind it.
Right. Technology is a tool. It can be used for good or bad. We need to make sure AI is used responsibly for the benefit of everyone.
What do you think is the biggest takeaway from the document?
For me, it's how everything is connected. The hardware, the algorithms, the data, it's all woven together, and understanding that is crucial in the digital world.
Yeah, it's like we've been given a map to this vast digital world, and we need to explore it responsibly and ethically.
And remember, technology is always changing. What we've learned is just the beginning. The future is full of possibilities and challenges, and we need to shape that future wisely.
Learning never stops, especially with IT. I hope our listeners keep exploring and asking questions.
Absolutely. Keep diving into the world of tech.
Well, I think that brings us to the end of our deep dive.
It's been a pleasure.
Thanks for joining me. It was great. And to our listeners, until next time, keep learning.